Welcome to this lecture series in coordinate geometry in straight lines. In this video, we will be solving all the problems that appeared in JEE mains, which were also about straight lines. So let's get started. The first problem we are discussing is the following. We have a triangle ABC lying in the first quadrant. So all the three vertices are in the first quadrant, and we are given the coordinates of two of them. So the coordinates of A are 1 and 1, 2, and that of B are 3 and 3, 1. So I have drawn it. And we are also given that angle BAC is 90. So wherever is the vertex C, this angle is 90 degrees. So either C is on this side or on that side. And we are also given that the area of triangle ABC is 5 root 5. What is the abscissa of vertex C? What is the x-coordinate? Abscissa is the same as the x-coordinate. So what is the x-coordinate of vertex C? Well, there are two possibilities potentially. If you go this way, you get something, or you go that way, you get something. But let's just find out this one. And since this has only one correct answer, I think, so we don't need to bother about the other one because I think the other one will automatically lie outside the first quadrant. Alright, so let's first find what is this length AC. To do that, first we locate or figure out the length of AB, but that is very easy because we know the coordinates of A and B. So the length of AB will turn out to be root 5 because 3 minus 1 whole square plus 2 minus 1 whole square and then a square root of that. That's root 5. And now what is the length of AC? Well, this is 90 degrees, so half times the length of AC times the length of AB is the area of the triangle ABC. And therefore, we have that, and that implies that the length of AC is 10 units. Okay. And now to find the abscissa of C, we first draw these two lines. So we draw this horizontal line, we draw this vertical line, and then another horizontal line. Okay. And now let us call this angle as theta. And if this is theta, then this is 90 minus theta. And since these two lines are parallel, this is also 90 minus theta. Okay. And now, what is the abscissa of C? The abscissa of C is, you drop this perpendicular and record this length and add the abscissa of A to it, right? That will be the abscissa of C. So once you note that, we can write the abscissa of C, which I am denoting like that, is the abscissa of A plus the length of AC times cos theta. Why? Because by definition of the cosine, if you drop this perpendicular, this length is cosine of theta times the length of AC. Just basic trigonometry. So we have that, and therefore this is equal to 1 plus 10 cos theta. And if we can find cos theta, we will be done. But cos theta is what? Cos theta is sine 90 minus theta, which is, now let us look at this triangle. Sine 90 minus theta is perpendicular upon hypotenuse. What is this perpendicular? The length of this is the y coordinate of A minus the y coordinate of B, which is equal to 1. So this is 1 and that is root 5. So we know sine 90 minus theta is 1 upon root 5. Okay, and now if we just use these two things, we get 1 plus cos theta is nothing but 1 plus 10 by root 5, which is 1 plus 2 root 5. So 1 plus 2 root 5 is here. Option B is the answer. If you go this way, if you had gone this way, I'm sure you'll get some negative abscissa, and therefore that will not show up in the options because the triangle lies in the first quadrant. Okay, so let's move on. Here is the next problem. So we have 2 points P and Q. The coordinates of P are given while the coordinates of Q are mysterious, where only the abscissa is the unknown. We have called it K. And it is given that the perpendicular bisector of this line segment has y-intercept. What is the meaning of y-intercept? Y-intercept means the y coordinate of the point of intersection of a line with the y-axis. So you draw the perpendicular bisector. Wherever it intersects the y-axis, you record the y-coordinate of it. So the y-intercept of the perpendicular bisector of these 2 points is given to be -4, and I have depicted that in this figure. Then we need to find what is a possible value of k. Alright, and it's very simple. Just use basic geometry. Since this is the perpendicular bisector, by congruency, this is equal to that. And if we use this equation, we will get a possible value of k. So let's do this. Let's call this point x. X is a bad idea. Let's call this a. So we are just using the fact that the length of PA is equal to the length of QA, which implies 1 square plus 8 square root. So what's going on? 1 minus 0 is 1 and 4 minus -4 is 8. So we are just using the formula for the distance. And this gives us k square plus 7 square root. Again, what's going on? K minus 0 is k and 3 minus -4 is 7. So if we square both the sides, we will get 65 equals k square plus 49, giving us, so what is this difference? This is 16, I think. So k has 2 possible values, plus and -4, and here -4 shows up in the options, 4 doesn't show up in the options, so option B is correct. And pictorially what is happening is Q is somewhere here, and if you draw the perpendicular bisector, you get this point. So there were 2 possible solutions for the point Q, but in the options only one features, and therefore we have option B as our answer. Okay, let's move on. So here is the next problem. We have a triangle ABC and the coordinates of the 3 vertices are given. I have drawn the diagram, and we need to find the coordinates of the orthocenter. So this is just a very straightforward problem. Just use the definition of the orthocenter. The orthocenter is the point in the triangle where the 3 altitudes meet. So it is a magical fact that the 3 altitudes of any triangle are concurrent. And to find the orthocenter, we will just write the equation of the altitude passing through A. We'll write the equation of the altitude passing through B, and find the point of intersection of these 2 lines. So that will be the strategy. Okay, so to find the equation of this line, we first need to find the slope of this, and once we know the slope of this, we will know the slope of that, because the product of slopes of 2 perpendicular lines is -1. Okay, so the slope of this line is 1 minus -5 divided by -7 minus 5. So that is -half. And slope of this is 7 minus -5 divided by -1 minus 5. So that is -2. Okay. Now we drop this perpendicular. So what is the slope of this guy? The slope of this guy multiplied by the slope of that guy is -1. So the slope of this guy is 2. Alright. And the other perpendicular, this one. This slope multiplied by that slope is -1, and therefore this slope is half. And now we can write the equation. Let's call this point D and that point E. So equation of AD is, what are we doing? Y minus 7 divided by x minus -1. So that's that expression, and that is equal to the slope of AD, which is 2. So that gives that the equation of AD is y equals 2x plus 9. And equation of BE, so that will be y minus 1 divided by x plus 7, because y minus 1 divided by x minus -7. This is the slope of BE, which is half. So that gives us y equals, or 2y equals x plus 9. So these are the two lines, and we simultaneously solve them. So multiply both sides by 2 of the above equation and subtract and whatnot. So you will get 0 is equal to 3x plus 9, right? Yeah. So x is -3 and y will be -2, I think, or maybe it's 2, because I substitute -3 here. This becomes a 6, and 2y equals 6 means y equals 2. No, this is actually 3, not 2. Because that becomes a 6, and 2y is 6 means y equals 3. So -3, 3 is the orthocenter, and therefore again option B is correct. Okay, great. So let's proceed. Yeah, so this time we have a triangle ABC, and again the coordinates of the 3 vertices are given. And P is a point inside the triangle such that these 3 areas, meaning the area of this and the area of that and the area of that, are all equal. So P is a very interesting point, and we need to find the length of the line segment PQ, where Q is some stupid point. So basically we need to find the coordinates of the point P. If we can do that, we can find this, the length of PQ. And one should be able to guess that point P is the centroid, because centroid certainly has this property that the 3 areas are equal. Let me justify why. What is the definition of the centroid? The centroid is the point where all 3 medians meet. So if P were the centroid, these 2 would be equal, these 2 would be equal, and these 3 would be equal. Now if we look at this small triangle, we have this median. Therefore this area and that area must be the same, because these 2 small triangles are over the same base, meaning the length of the bases are the same, and of course the height is the same. So these 2 small triangles have the same area. So basically if you draw the 3 medians, this area and that area is equal, this area and that area is equal, and these 2 areas are equal. But at the same time, this area and that area is also equal, and similarly for the other 2 vertices. So you'll end up proving that actually all these 6 small triangles have the same area. So to summarize, if P were the centroid, then extending these would mean this area is equal to that area is equal to that is equal to that is equal to that is equal to that, and hence this condition is satisfied. Now could there be some other point satisfying this condition? No, and that's very interesting. Why? Because let's just find the locus of all the points P which have the property that these 2 areas are equal. Let's forget about the third triangle for the moment. Let's just find the locus of the point P such that these 2 areas are equal. And locus just means a set of points. Find the set of points P such that this area is equal to that area. Locus is just a fancy word. Okay, so when does that happen? You can easily show that that locus is a straight line because let's say it happens, suppose I have a point P which has the property that this area is equal to that area. So then what should happen? Then this perpendicular times that length should be equal to that perpendicular times that length. We're just using half times base times height is the area. And therefore the ratio of the lengths of these two perpendiculars is the ratio of these two sides. And therefore this thing is a straight line. So that I leave to you. So this is a straight line, and we already know that median has that property. If this were the median, then this property is true, that these two areas are the same by the argument we gave. So necessarily the point P must lie on the median, and therefore also this median and that median, and therefore P is the centroid. So I argued that P necessarily must be the centroid, though I did not give a too detailed of an argument. I hope I have elaborated the main steps sufficiently well. And if you feel that there is still some room for justification, I suggest you should stay on this. So anyway, so P is necessarily the centroid, and therefore we can find its coordinates, because the coordinates of the centroid are add the x coordinates, divide by 3, and add the y coordinates and divide by 3. So the point P is nothing but 1 plus 6 plus 3 by 2 divided by 3, comma 0 plus 2 plus 6 divided by 3, which is, God knows what that is, 7, 14 plus 3, 17 by 6, comma 8 by 3. Alright, and therefore PQ as length, we know the coordinates of P, we know the coordinates of Q, so subtract the x coordinates, you get 24 by 6. We square it, and 8 by 3 minus 1 by 3, that's unfortunately 7 by 3. Wow, that's bad. Did we make a mistake? 0 plus 2 plus 6 is 8, divide that by 3. If Q were minus 1 by 3, it would be better, right? Maybe I copied the problem wrong. Okay, I don't know. Maybe I copied it wrong. So, okay, anyway, so let me not compute this. You know the coordinates of P, you know the coordinates of Q, so you can just calculate the distance between P and Q. I think I may have copied the problem wrong. If this were minus 1 by 3, the computation would be much more pleasant. Okay, so there's nothing to it apart from this observation that P is the centroid. So this problem is actually a good problem compared to the rest. Okay. So now we have a triangle whose coordinates are these 3 points, and C is the centroid of the triangle, and P is the point of intersection of these two lines. This is some data that is given to us. So we need to find, what is being asked. So consider the line passing through the point C and the point P, and which points among them also lie on that line. Again, this is a very, very straightforward problem. Find the coordinates of C, find the point of intersection, write the equation of the line passing through C and P, and check by substituting these on that line which one does indeed satisfy. That's it. Let me do it, but it's kind of underwhelming. So what are the coordinates of C? The coordinates of C are this thing divided by 3, comma that thing divided by 3, which is equal to 2, 2. 2, 2. And what is the point of intersection of these two lines? And let us just do this in rough. So if I multiply by 3 on both sides, I get 3x plus 9y minus 3 is 0. And I already have 3x minus y plus 1 equals 0. If I subtract, I get 10y minus 4 equals 0. So y is 2 by 5. Okay, y is 2 by 5. And therefore 3x is 2 by 5 minus 1, which is minus 3 by 5. And therefore x is minus 1 by 5. So the coordinates of P are minus 1 by 5 and 2 by 5. Okay. So P is that. And therefore the equation of the line passing through P and C is... I'll justify this. Yeah, so what's happening? We have the point P, we have the point C. So the equation of the line passing through this is the slope of the line, right? Because 2 minus 2 by 5 and 2 minus 1 by 5. We have just taken the ratio. So that's the slope of the line PC, and 2, 2 is a point through which this line passes. So we have this equation. Okay, wonderful. So this equals that, and this equals that, which is 8 by 11. So we get 11y minus 22 is equal to 8x minus 16, and therefore the equation is 11y equals 8x plus 6. And now we have to undertake the tedious task of finding which one satisfies this equation. For the first one, we get minus 72 plus 6 on the right hand side. Oh, I think that works. So the right hand side is minus 72 plus 6, which is minus 66. And the left hand side is also minus 66. So this definitely is something that satisfies it. What about that one? I don't think so, because that would be 72 plus 6, which is 78. And that would be 77. So that doesn't work. That's 56 plus 6, which is 62, and that would be 66, so no. And that's minus 72 plus 6, which is minus 66, and that's minus 77. So only option A is the correct thing. So answer is option A. Okay, this is fine. Let's move on. Alright, so now we have a line L in the plane whose x and y intercepts are 3 and 1. So the line passes through 3, 0 and 0, 1. We need to find the image of this point, which is here, under this line. What does that mean? Think of this as a mirror and reflect. So geometrically, what do we need to do? Drop this perpendicular line and identify a point here such that these two things are equal. So that's what we need to do. Okay, so it helps to draw a diagram. So let's say this is the reflected point. Its coordinates are a, b. Okay. So, I mean, there may be various ways to doing this. One way to do this is you use the fact that this distance and, use the fact that this distance and that distance are equal, and this distance and that distance are equal. You get two horrible equations. You solve both of them. You should be able to find the point a, b. But let's do it in a somewhat cleverer way. The first thing is that the slope of this thing is such that if you multiply the slope with this, you get minus 1. Because these two lines are perpendicular. So the product of slope of these two things is minus 1. And the other thing is that the midpoint of these 2 points lies on this line. So if we use these two facts, we should be able to locate a, b, and we will only be dealing with linear equations in the process. If we go by this distance approach, we will be dealing with quadratic equations. So the computation will be heavier, but this should be much smoother. Okay, so what is the slope of this line? The slope of this line is b plus 4 divided by a plus 1. That multiplied by the slope of this line would give us 1 divided by minus 3 equal to minus 1, because the product of slopes of two perpendicular lines is minus 1. So we get b plus 4 equals 3 times a plus 1, which gives us this. So that's one equation. And the other equation is, if we take the midpoint of these 2 points, it should lie here because this has been perpendicularly bisected by that line, right? Reflection exactly means that. Okay, so what is the midpoint? The midpoint is midpoint is a minus 1 by 2 comma b minus 4 by 2. How do you find the midpoint of 2 points? You add the x coordinates, divide by 2, you add the y coordinates, divide by 2. So that's how you get the midpoint, but that lies on this line. Okay, so what is the equation of this line? Let's find the equation of this line and substitute that point in it. The equation of that line is y upon x minus 3 equals 1 upon minus 3, which gives us, yeah, that is the equation of this line, and this is satisfied by the midpoint. So we get that, which gives us, let's multiply by 2 on both sides. Yeah, and since I don't have space, I will mess around here itself. I get 19 on this side. So we have these two equations. Okay, and let's multiply by 3 on both sides to get that. Okay, and now if we look at this one and that one and add both of them, we will get 22 is 10a. Right, so just solving those two boxes, we get a is 22 by 10, which is 11 by 5. Is that there in the options? Yeah, it is there, at least here. What do we get for b? B would be, just using this, 3 times 11 by 5 minus 1. That's 33 by 5 minus 1, which is 28 by 5. So yes, option A matches, and that's the answer. Okay, very nice. Let's move on. So here we have a line which is at a distance of 1 by root 5 and 2 by root 5 from these two lines respectively. What does that mean? This line is at a distance of 1 by root 5 from this line and is at a distance of 2 by root 5 from that line. What is the sum of all possible values of alpha and beta? Okay, so first note that for this problem to even make sense, these three lines must be parallel, because to ask for the distance between two lines, the two lines must be parallel. Okay, and that is true because the slope of this is 2, the slope of that is also 2, and the slope of this is also 2. So the three lines are indeed parallel. And now since this is at a distance of 1 by root 5 from this line could be either here or there at a distance of 1 by root 5. So there will be two values of alpha, and similarly there will be two values of beta, and we'll just have to sum up the four values. Okay, fine. So how will we do it? First, let us locate a point on this line, and the most convenient point is the y-intercept, which is 0, 3. Yeah, so to find the y-intercept, we just substitute x equals 0 and calculate the y-coordinate. And we'll just take the distance from this point to this line. And that distance is, if you remember the formula of the distance between a point and a line, that distance is 4 times 0 minus 2 times 3 plus alpha, absolute value, divided by that number. So 4 square, 2 square. Yeah, I'm sure you remember the distance formula. And this is equal to 1 by root 5. So we get this is what we get, and therefore alpha has these two possibilities, 8 and 4. So those are the two possibilities for alpha. Similarly, you do the same thing for beta. Find the two possibilities for beta and just add the 4 values. So let me not compute. Okay. All right, so I think this is the last problem. Yeah, so the locus of the midpoints of the perpendiculars drawn from points of the line this one to the line that one is. So what is the question? You pick a point on this line, you drop a perpendicular, you take the midpoint. You take another point, drop the perpendicular, take the midpoint. And you keep doing this. You will accumulate a set of points, and finding the locus just means describe those set of points. What is the best way you can describe it? And here your options already suggest that it is going to be a straight line. That's not a mystery. If you just use your basic geometry education, you will easily be able to see that it is a straight line. The whole point is to find its slope. So to find its slope, just pick any point. Just pick any point on this line. The most convenient would be when you substitute y equals 1. So you'll get x equals 2. So one such point is therefore 2, 1. And we drop this perpendicular. And we need to find what is the coordinate of the midpoint, and that will give us the slope. Okay. So yeah, how shall we do it? Yeah, I mean, there must be various ways, but what is the most efficient way? Okay, so let's just try to locate the coordinates of this point. Wherever this perpendicular lands, let's just try to locate the coordinates of that point. And since this point lies on this line, the coordinates of this point would be a comma a for some a. So let's say this is a comma a. And we can just now use the fact that this slope times that slope is -1, because the product of slopes of two perpendicular lines is -1. So, okay, let's do that. So we get a minus 1 divided by a minus 2, which is the slope of this line, times the slope of the line x equals y, which is 1. This is equal to -1, so we get a minus 1 equals this number, which gives us 2a equals 3, and therefore a is 3 by 2. Okay, so a is 3 by 2, and therefore the midpoint of these 2 points is a plus 1 by 2. Sorry, the x coordinate would be a plus 2 by 2, and the y coordinate is a plus 1 by 2. So the midpoint, let's call it m, is equal to that, which is, I think that would be 7 by 4. Yeah, because a plus 2 is 3 by 2 plus 2, which is 7 by 2, and then there's the denominator of 2. And a plus 1 by 2 would be 5 by 4. Okay, so that's 7 by 4 comma y by 5 by 4. So the slope of this line is 5 by 7, and it passes through the origin. So y minus 5 by 7, or I should just say y by x, or to be even more precise, y minus 0 upon x minus 0 is 5 by 7. Yeah, and therefore we get 7y minus 5x equals 0. 7y minus 5x equals 0, which is here, and therefore option B is the correct answer. Okay, so I hope you followed. All we are doing is, if we choose a point here, we can find the midpoint of this perpendicular via this trick. All I did was this, I chose this special point. Why? Because I already know the locus of the points is going to be a straight line passing through the origin. That I know because of my geometry knowledge. So if I just pick one point on this line and find the midpoint, I will be able to locate this line. That's all. And I just chose this point arbitrarily. We found this foot of the perpendicular via this trick, that the product of slopes is -1. And once we find the coordinate of this point, we can find the coordinate of the midpoint, and then we can write the equation of this line. That's all. Alright, so with that I want to end this. As usual, like, comment, share, subscribe, and I will see you next time.